Don't update it. Yeah.
Ready to start?
Yes.
Excellent.
Let's do it.
Tonight's going to be a little less formal than our usual informal meetings. But we have a full set of topics to cover. And we'll just see how far we get with them. But first, let's take a look at the schedule on our calendar. Notice Saturday, March 9th, this coming Saturday at 3 o'clock is a planetarium open house at the Manheim Township Planetarium. And as usual, if you click on these, you can find out more about them, timing, things like that. There's even a map about where it is. This is a free event, so, and it runs from 3 p.m. to 5 p.m. And includes a number of activities that you can read about on the web. And then, this is the April meeting. We have a, which will be here as usual. We have an outside speaker, Bob Nye, which I think all of you know, or most of you. He's going to discuss a cosmic conundrum, which is basically the disconnect between two approaches to how to analyze the expansion rate of the universe, and they're coming up with different answers. In science, that's a problem, or maybe an opportunity. In other words, they've got to figure out what that difference is. It should be a lot of fun, and I would encourage everyone to come to that one. Let's see, I don't need you. And then next, there's going to be a Muddy Run Observatory open house on Saturday, April 6th. And once again, you can get a lot more details about this just by clicking here. And there's also a map about where the Muddy Run Observatory is. It's a lot of fun. It's in the south end of the county. It's probably about 45 miles from here, maybe a bit less, about 30 minutes south of the city of Lancaster. Excellent facility and very entertaining. And then, let's see, another Star Watch at the Manheim Township High School. And then we have an event coming up in April, Stars Over the Susquehanna. That will be down at the, once again, click on it for more details. That's going to be down at the Columbia Trail Visitor Center in Columbia, Pennsylvania, right along the river. We'll be doing a Star Watch there. We did one last year. We're using the same format. So we're going to be giving an inside talk followed by outside activity with the telescopes if the weather's decent. And let's see, there were, without going into May, there are a couple of other things. Come on. North Museum Astronomy Day. Do you want to talk about that for just a minute?
Sure, we can do that. For a couple of years now, the North Museum of Nature and Science has been celebrating National Astronomy Day. And the date for that changes from year to year. It's actually based on, I think, the first quarter moon after Easter. So last year was in April, this year is in May, and the actual date is May 11th. And I've invited both the AALC and also the York County Astronomical Society to help participate and provide some astronomy activities for the community and for our visitors. And both have agreed to do so. And so I'm sure the club could use some extra help to represent the club and also just to spark some curiosity with those that come. There will be planetarium programs, and then there's a possibility that there might be some other talks, one from each club. And in the evening, we've also made arrangements with the Grundy Observatory owned by Franklin and Marshall College to open up the doors for some public observing. And I'm still trying to work to see if I can partner up with some other folks as well to try to start to branch out and do maybe a community-wide type of star watch. But that's for down the road.
Okay, thank you. The other thing I want to make everyone aware of, well, two things. One is the Northeast Astronomy Forum. We just call it NEAF, N-E-A-F. That's April 6th and 7th, which is a Saturday and a Sunday. There are two big things about this. It's a pretty good drive, about 3.5, 4 hours from here, in Suffern, New York. But it's easy to get to. That is, you're taking interstates all the way until you hit New Jersey traffic. And if you want to see the biggest display of astronomy equipment in the world, that's the place to go. I mean, it's really amazing. It's a huge gymnasium. They just fill with exhibits. A lot of the vendors, whether you're looking at telescopes or astronomy cameras or whatever, they usually have special pricing there. And it's well worth just walking through at least once to see everything that's there. Yes?
Mike, I'm looking for anybody who wants to go along. Two of my ex-friends are going this year.
Okay, count me in.
All right,
I'm going to go, so
all right,
you save me the drawing.
all right, let's do that.
Thank you. So if anybody else wants to go, there's your room. How much room do you have?
4-seater at least,
Okay. So 2 more.
and then room to bring telescopes home too.
The other thing is they have excellent speakers there too. So a lot of good talks, a lot of things. Really worthwhile. Final thing, Cherry Springs Star Party up at Cherry Springs State Park, which is in Potter County, Pennsylvania. It's about 4 hours north of here, depending on how fast you drive. And the Cherry Springs Star Party, does anybody remember what the dates are?
May 30th through June 1st.
Yep.
Thursday, Friday, Saturday. Actually, yep, Thursday, Friday, Saturday.
Cherry Springs Star Party 2019, come on. And
Oh, no. So,
There you
so
go.
Second, okay, second.
May 30th to June 2nd. And it's called a Star Party. To me, it's an astronomy festival. Once again, talks, a few vendors on the site, nothing like beef. But you're also sitting under one of the darkest skies on the East Coast. And you can see how it makes a huge difference in how you look at the night sky. You can just see so much more, even with just your eyes. It's mainly a camping event. And people that register there usually go for overnight, or 2 or 3 or 4 nights even, depending on the weather. And it's primitive camping in the sense that there are no showers. It is a catered event, so there's food. You do have real bathrooms, all right? But everything else you have to bring yourselves. Any questions about that?
What kind of food is it? Because I remember when I went there, it was a little food truck or something like that. So.
You can live off of it, but not well.
It's not just hot dogs and pizza, it's other stuff.
Yeah, if you like pizza or hoagies or things like that, you're going to be okay.
Okay. It's not zagging.
It's worth mentioning that,
Speak up.
it's worth mentioning that if you have the kind of car where your lights go on automatically, your headlights, they will hate you. So you have to figure out how to get them off.
It can get you kicked out of the park.
Or somebody hammering with it.
Yeah. Yeah, unfortunately, my new car, I can't really switch some of the lights off, so I've got a routine now where, you know, the car gets closed up in the evening, and I just don't open it till the next morning. I make sure I got all the stuff out that I need. Good point.
Can you take an RV there or no?
You can take an RV there, yes. Cheryl?
For anybody who wants to go to Cherry Springs, there's all kinds of instructions on the Cherry Springs and the Star Party's websites. It tells you the do's and don'ts of everything.
Yes.
I don't know if that's, I know Black Forest has it, I'm not sure if it's Cherry Springs State Park or Black Forest Star Party, or if there's links on it. And then there's a map, I think, that you can download and print out of the layout of the astronomy field.
Yeah, just look up Cherry Springs Star Party, and there's lots of information out there, including what Shirley said,
And
as well as people talking about their experiences.
Well, across the street was a campsite over there. You could, you know, headlights and stuff are okay.
Yes.
But they redid all that. Instead of having public viewing night on the astronomy field, all public viewing is across the street. They have a big screen now, and I think telescopes out there that they can project onto the screen, and they have seating out there. So people, the public doesn't have to walk through the astronomy field and walking over everybody's cords and in the dark and all that kind of thing, because I guess they had some issues with that. But it's really, really nice. And then there's bathrooms over there too. So you just park, if anybody wants to go out for the night, you can just park in that parking lot, and the bathrooms are there. I'm not sure about food or munchies or anything, but you can still camp there, and they have a nice observing area for the public.
Okay, any questions about any of that?
Just one last, I was 2 years ago at Black Forest. Is Cherry Springs about the same level of attendance?
Yes. Yeah, they're virtually identical.
No, and I know from Mass, you know, you sign up for both and hope to get good weather at least for one.
At least one, yes, I do the same thing. Okay, let's move on to Rob.
All right.
The floor is yours.
Yeah, we'll have to change that. Anybody, has anybody been checking out the planets in the morning? These mornings? Very early, okay, no one's up like me, okay. Yeah, so basically, now I showed you last month some of the, that's loud. Some of the pictures you can get, and that's pretty much what we got going on for March. I'm going to let myself speak for myself.
Hi everybody, and welcome to Observing with Webb, where a high school astronomy teacher tells you
There you go.
what you're looking at, why it's so cool, and what you should check out later this month at night. Don't forget to check out my Podbean page, mrwebb.podbean.com. You're watching this on YouTube, but I have other stuff up there as well, and also my Twitter feed at MrWebbPV. And you can get this as a podcast on Stitcher and iTunes. Just search for Observing with Webb. But anyway, welcome to March of 2019. We've got a great morning lineup in the beginning of the month. We have all the naked eye planets are visible at some point during the month, and also we have a great lineup at the end of the month, and that's really making March a great morning planetary astronomy month. Here I am in the Pequot Valley Planetarium, a new area, because, well, it takes me a while to get these things together, and I'm doing this at the last minute. But anyway, take a look up here. We've got some planets to talk about. So which planets can you see at night? Well, you got to get out after sunset, and there's two you might be able to catch. Let me start off with the highest one and the easiest one to find, and that would be Mars up here. Mars is going to be up there in the southwest, and it's going to be up there until about 10:30 or so at night. And it's going to be up there being very red, brighter than its surroundings, and in Aries. What's going to happen throughout the month is Mars is actually going to travel up toward Taurus, and hopefully in, what's next month, April, it'll be up there in Taurus, looking really cool. But Mars is up there, not too bright, pretty neat. The cooler one, or the more rewarding one to find at the beginning of the month is Mercury. Now Mercury is only there for about the first week. So I had this set for sunset, but I went a little bit past, and watch what happens throughout the first week. One night it's about 10 degrees above the horizon, and then it gets a little lower, a little lower, a little lower, and then it dives down below the horizon. So you'll only be able to see Mercury in the sunset for about the first week of March. Anyway, so that means you can see Mars and maybe Mercury during that first week.
Anybody get to see Mercury this week? All right, nice. How easy is it to spot when it's that low?
Not easy, but if you know what to look for, you'll find it.
Okay.
I use binoculars.
Binocular, okay.
All right, so what about the other planets? Well, if we take a look at this green line here, which is the ecliptic, there's no other planets up there until, well, let's go through the time. Let's see, keep going, 9, 10, 11, 12, oh, Jupiter kind of rises around 2 in the morning, between 2 and 3 in the morning. It's going to be very bright, and if you know your constellations and it's dark out, it'll be near Scorpius and underneath Ophiuchus. I don't know many people who know about Ophiuchus. And then you'll also see Saturn below that, rising a bit later, and Venus below that, also rising a bit later. So let's talk about these morning planets, okay? You're going to see Venus, Saturn, and Jupiter. Let me go back to the 1st of March, and you notice that, well, let's get the moon out of there, okay? You'll see that Venus, Saturn, and Jupiter's pretty far off to the right. Now what happens throughout the month is Saturn and Jupiter pretty much veer away from Venus, and Venus is sort of off to the left, and there's this big gap between Saturn and Jupiter. And that's fine. But you'll see these 3 in the morning throughout the month. Venus is going to be the very, very bright one, but low on the horizon. Jupiter is going to be the one that is bright, but not as bright, but far off to the right. And Saturn is going to be the bright, less bright than those, but still brighter than the stars. It's going to be in the middle between those. And, oh, what do you see here? Well, Mercury started popping up. Now let me change the timing just a little bit and go to sunrise. And that's right at sunrise. Let me go back a little bit. Mercury is just above the horizon there for about the last week. So Mercury is actually a really interesting planet because what happens is it starts out the month by the sun as an evening planet, and then at the end of the month, it's actually going around behind the sun. And as it goes behind the sun, it reappears on this side of the sun. Oh no, sorry, it's going in front. It reappears and then we can see it in the morning as well. So anyway, pretty cool. So don't forget, you've got Mercury, Venus, Saturn, and Jupiter in the mornings. Mercury only that last week. And I'm going to talk about how the moon sort of travels through there a little bit later. All right, so what events do we have going on in March? Well, first of all, let's talk about the moon. We've got a new moon on the 6th, which means basically those first 2 weeks are pretty dark skies. And anytime after the 6th, you should see a very nice crescent moon after sunset. Then the first quarter moon is on the 14th, right at mid-month. So as the March Madness begins, you'll start seeing the first quarter moon, and then we'll have a full moon on the 20th. That's when it's visible all night and completely lit up. And then we also have the last quarter moon on the 27th. That's visible starting around midnight and into the morning. And then we start getting into some darker skies. There, what's going on?
I'm just going to fast forward past, the stuff that's already happened in the past. So
March 11th. Well, we have to switch and go back to our sunset sky. and we have to look toward the west, and what we'll find is a nice close encounter between the moon and Mars. As long as you get out after dinner, you should be able to see the moon and Mars up here in the west. And you'll see them, let's see, it looks like it'll be a crescent moon and beautiful red Mars. You might even be able to get them in one picture. And yeah, it's just going to be really nice. They'll be close together. So if you have trouble finding Mars, March 11th is the night that you want to go out. They're only about 6 degrees apart, which again is about 3 finger widths held at arm's length. Okay? And they will set around 11 p.m. Eastern Daylight Time. Okay? Then on March 20th is the spring equinox. There's nothing to show you here, but it's really just astronomically the first day of spring, even though I would think astronomically that should be the middle of spring, but that's another story that requires graphs and visuals and stuff. But anyway, that is the first day of spring, and yeah, so check it out, 20th. And then lastly, we have another morning lineup, which again goes into April. So what time of day is it going to be? You guessed it, it's going to be in the morning. And on the morning of March 25th, if you go out at 5:40, that should probably be closer to 6:40 because of daylight savings time. But anyway, go out there when it's still dark on the 25th, and you'll see the nice gibbous moon way over here. Jupiter is going to be about 20 degrees to the left. Saturn is going to be to the left of that. Venus to the left of that, and Mercury you might be able to catch very low on the horizon as well. Now the planets are going to stay basically in the same spot, but the moon's going to pass through. And so let me move ahead and show you what's going to happen. So the moon actually gets closer to Jupiter on the 26th. Now they're only 8 degrees apart. The moon moves about 12 degrees along the ecliptic every day. And so you still have a really cool lineup out there. Then, the next day, the moon actually pops between Jupiter and Saturn, but is still pretty close to Jupiter, only about 4 degrees to the left. And then the next day, now the moon's closer to Saturn, right? I don't know how, that's probably about 10 degrees or so, something like that. And then on March 29th, now the crescent moon is actually pretty close to Saturn. In fact, it is 3 degrees down and to the left of Saturn. So that's probably like 2 fingers widths at arm's length. But then the following morning, the moon is in between Saturn and Venus, but closer to Saturn. Next morning, the 31st, a beautiful crescent will be almost halfway between Venus and Saturn, a little bit closer to Venus. And then April 1st, okay, let's refocus here, okay? April 1st and April 2nd is really the last day for this sort of thing. These might actually be hard to find because they are low on the horizon. Dawn is probably breaking, but I don't know, find a very clear horizon and it could work for you, okay? So if you go to April 1st, Venus and the moon, very thin crescent moon, they will be only about 10 degrees apart. That's 1 fist width held at arm's length, okay? And then on the 2nd, this is going to be the hardest. I would be surprised if I could even find this, but I do have a place that I stop on my ride into school that has a very clear view toward the horizon, over lots of farmland, nothing in the way. I might be able to catch this. But you will see the moon directly below Venus. In fact, if we zoom in a little bit more, the moon will be directly below Venus by about 4 degrees, and Mercury will be over here. And that's going to make a really cool triangle. I would be very impressed if anybody got a really good picture of that. So that is the events for the month. Basically just those 2 lineups, but it's happening at a time where if you are driving into work around 6 in the morning, maybe even 7 in the morning, you might actually see some of this. So get out there, take pictures, and share it with me.
All right, then we get into the constellations, but I believe you guys know a bit more about constellations. So any questions about stuff that's going on this month?
When's the weather gonna warm up?
Later. Now, Eric Hurst did say that today should be the coldest day until next winter. checking out the planets in the morning at all? What's that?
Occasionally.
Yeah. You have to be up at that point, and it has to be clear. Anybody do any other observing? Go through telescopes, anything cool this month? It is too cold. It is far too cold. All right?
I've just been out in the alley with my binoculars and tripod and looking around Nebula trying to find those three globular clusters.
Mm-hmm.
But there's three clusters in Auriga or Orion.
Mm-hmm.
And so then by then I'm too cold. If I found the three, then I'm happy.
Yeah, yeah. And with this snow, I gotta shovel off my deck if I'm gonna do anything.
I live in town, so.
Okay. Hang on just a second. Okay. How many people look at the sun in white light? How many people have a solar filter to do that? Okay. There is a new sunspot. Unfortunately, it appears to be part of the previous solar cycle, so we still haven't advanced into the new cycle yet. So the sun is really taking its time getting through its minimum.
A quick question about the sun. Just mentioned that Mercury went from one side of the sun to the other in front. Did it transit? Or?
No, that's November the 11th, I think.
So is the line of the orbit above or below it?
It's across it. Well, right now, you mean this current
Well,
passage of Mercury around the sun? It's either above or below.
you just mentioned it was it's an evening sort of star now, a unit planet, and then the month and it's a morning
Right.
one.
Mm-hmm.
That means it went from one side to the other. Did it go behind?
I went
Go
in front, pretty sure.
Is it then
Mercury?
transit?
Yeah.
No, it's either passing above or below, I don't know.
Okay,
The
and
cycle.
or
So
it's
it's
not
not
the
crossing
same
that sort of.
not the same plane.
But I think it's November the 11th, it does cross
Okay.
the sun. And that'll be an event we'll talk about eventually.
That's the
Well
plane
worth
of
watching.
Mercury's orbit, so like this and ours, a little bit like that.
Right.
An inclination to it, a couple degrees the other way, so
Exactly.
it translated.
Excuse me.
Okay, deep sky objects for March. First of all, what I want to talk about here is when you're going to do deep sky observing, first you want the moon glare involved. So what I have for March, the dates where you're not going to have moon glare is February 25th through March 11th, and March 26th through April 9th. And the way this is worked out is it's the 6th night after the full moon through the 3rd night before the first quarter. The reason for that is if you're looking at, Robin mentioned that first quarter is going to be in the 14th. So the 3rd night before the first quarter, about the 11th, which means is, you're going to have the crescent moon is going to set earlier at night until you get closer to the first quarter, then it's almost at the meridian. So it gives you some time to let the moon set, maybe do some observing of the moon, and then you're going to have it dark enough to do deep sky. The full moon, the 6th night after the full moon, because as that progresses, the 6th night's going to be, it's going to only rise around after midnight. So at least you got the time when it gets dark till about midnight or subsequently after that 1 or 2 a.m. to actually observe. And what I do each year is I look at where the first quarter and the full moon is, and I just take a calendar and I just put a red line through each month so I can just at a glance look at when the time to get the telescopes out or make planning for observing. So that's what I do, and it works quite well instead of having to look it up all the time. So just get a new calendar and do it up. Spring stars. I mean, that's what it looks like now too. We got snow on the ground, but at least that we can start to see the spring stars now coming out. And the constellations I want to look at and talk about some of the deep sky objects that are Cancer, Hydra, and Lynx. And here's a star map. right here's the meridian, of course, that's the line that goes from north and south. This is looking at south, this is about the 9 p.m. Eastern Daylight Time. Of course, we're going to switch the clocks on Sunday the 10th. But you're looking at Hydra right here, and then of course Cancer. We're talking about spring stars. Here's Virgo coming up. Leo's going to be coming up in the east. And then of course Lynx is between Ursa Major and Origo. So that's what we'll be talking about. But what I want to mention though is before the winter goes away, is your last chance to really see Orion, the Great Nebula. So, I mean, and all you need is a pair of binoculars. You just step out in the cold and take a look at it, but it's going to be good for another month. I mean, around 8 p.m. it's going to be, Eastern Daylight Time is going to be directly south. And subsequently it's going to move to the west then. But, you know, as I mentioned, without the moon's glare, you know, up to the 11th or Monday, and then later in the month, from the 26th through April 9th is a good time to look at it. And this is what it's going to look like in a pair of about 20 by 80 binoculars. But I mean, a good pair of 7 by 50s or 8 or 10 by 20s are going to be, or 10 by 50s rather, are good. You'll be able to see. You can see with the naked eye if you don't have much, you know, glare from light pollution. And that's what a typical look would look like in a small telescope. So it's a very nice, it's a very close nebula, and this is a star-forming nursery. New stars are being formed here. I'll speak about that a little bit later. But it's a beautiful winter object to look at. So like I said, you only need a pair of binoculars. You just want to step out and take a look. You know, and while you're at it, take a look at the Pleiades, which are going to be to the upper right of Orion in the south. It's a cluster. It's about 100 million years old, probably a modern age cluster. It's very close, 444 light years. And that's a typical binocular view. It looks great in a pair of binoculars. In fact, this is an open cluster that you probably look at better in binoculars than a telescope. As I mentioned, it's going to be high up in the southwest at 8 p.m. Eastern.
Tom, excuse me, when does daylight time start?
This Sunday.
It's March 10th, not April.
Did I say, yeah, March 10th? Oh, yeah,
Yeah.
Keep changing it, so it's, yeah. Now, I wanted to show this. This is a picture I took of the Canon Power Shot. And all it was is of the eclipse in January. And I just used a point and shoot camera, I put it on a tripod. And of course, it was so cold then, I just went out when I could and took a snap-shot and came back in. I was watching through my skylight because it was too cold, if you remember. But I showed this because, you know, you can, even with a simple camera, you can take some pretty good shots, especially if a bright object like the moon. And I thought they came out, it's on automatic, I had it just press the button and bingo, you know, I had some good shots with it. On the table down here in the back against the wall, Dan Foster, a club member, has taken pictures with a better camera than this one. It's a Canon Rebel, and he has got a lot of deep sky shots, and he put those on some ceramic tiles with covered that with resin, so he's did a nice job of that. And you can take a look at those before you leave tonight. But I just want to point that out that, you know, you don't need a fancy $2,000 camera to take some decent pictures of, especially the moon. Okay, looking at the deep sky objects, first of all, the Cancer. And there's a nice spiral galaxy about 10th magnitude, 4.3 arc minutes by 3.3. So it has a bright halo, has a large core with a tiny bright nucleus. This is a picture what it would look like in a typical telescope view. And this is a Hubble image. And of course, it's a lot more resolution, but you can see a lot of spiral arms and a lot of all these blue areas, a lot of star-forming regions there. So it's a very active galaxy where a lot of stars are being formed. And it's about 55 million light years distant, and it's 70,000 light years in diameter. Now, it's about 3/4 the size of our Milky Way, which is about 100,000 light years in diameter. Okay, the Beehive cluster. This is a nice cluster that spans about 1.5 degrees, so it's really a good, you can see with the naked eye. but it's good in binoculars. Again, I think it's more of a binocular object. But I want to mention, this is one of the only, probably the only type of object as a cluster. If you look at it, if you have decent skies and you can, see the sickle of Leo, it's going to be the right side where you have Cancer. And right in the middle of Cancer will be the Beehive cluster. If you look at it directly, if you don't have much light pollution, it's going to look like a fuzzy blur. But as soon as you avert and do averted vision, you just look to the side, your peripheral, it'll snap. You'll be able to resolve all the stars. It's the only cluster that actually allows you to do that. And that's because when you're aiming to the side and looking at it, you're using the rods in your eye, which are most sensitive to the night. But that's one of the objects. Look at it fuzzy and just kind of turn your head and keep looking at it to your peripheral, and all of a sudden it'll pop in. You'll see the star.
Naked eye, you mean?
Naked eye.
Yeah.
Yeah. It's pretty dramatic too. If you can see it as a fuzz ball and you just do that, it'll all of a sudden you resolve the stars with your naked eye. But it's a good one to look at with a pair of binoculars. So if you're out there looking at Orion, the Great Nebula, and you go up to Pleiades, and you're going to see to the upper left of Orion, you're going to see the sickle of Leo, and right there's M44. So take a look at that before you run back in. It gets too cold, but hopefully the weather's going to get better later in the month. And where these objects look, I mentioned here's the sickle of Leo, Regulus. And of course, right in the center here next to Delta is M44. And of course, I mentioned the galaxy here, NGC 2775. And right between the two, there's another Messier object, M67, which is a nice open cluster that you can look at with a pair of binoculars also. Okay, next constellation is Hydra, the water snake. Now this is the largest of the 88 constellations in the sky. It measures 1,303 square degrees of sky and spans over 100 degrees in length. So you can see where it starts down here below Virgo, loops around below Crater and Corvus, up to the head here, which is below Gemini. So it's just a very long, narrow, but it spans quite a bit of sky. And globular cluster, a nice one in Hydra is M Messier 68. It's 7.7 magnitude, which means you can see that with a pair of binoculars. The sky's dark enough. It's about 12 arc minutes in diameter, which is roughly, about 1/4 the size of the full moon, which is about 30 arc minutes. And it's a binocular and telescope object, 33,000 light years distant, but highly eccentric orbit, takes it as far out as 100,000 light years from the Milky Way. And of course, it's going to be orbiting around that central portion of the Milky Way. It also displays signs of being in rotation, and thus it may have been acquired by our galaxy through accretion of a satellite galaxy. In fact, they think where a lot of these major globular clusters came from is maybe the cores of small dwarf galaxies that the Milky Way had grabbed in with its gravity and absorbed the gas and dust, and that's the central core that was circling around the main core of the Milky Way. There's a Hubble image of it, which really shows a lot of resolution of stars. We're talking, several 100,000 stars packed in that ball. It's about 11.2 billion years old and is metal core. So these are ones that formed way back when the galaxy was first forming. And they're very old. Usually you're talking about red giants and yellow type stars here, indicating old stars like the sun. Here's a nice galaxy in Hydra also, M83, Messier 83, barge spiral, 7.6 magnitude, which means you can see that with binoculars also. It's a nice size too, 15.5 by 13, which is about half the size of the moon, arc minutes. It's nearly face on, and it's 15 million light years distant. Now the Andromeda galaxy is 2.5, so this is a bit further than that. It's also called the southern pinwheel, since it's similar to spiral structure of M101 in Ursa Major. Also M33 in Triangulum is also called a pinwheel. It depends on who's, a lot of amateurs call, M1 on one pinwheel, also M33, but this is considered the southern pinwheel. 6 supernovae have been observed in this galaxy in the past 100 years. But you can see again with the Hubble image, you can see all these areas of red, which is hydrogen gas and dust, and all these bright blue areas are actually star-forming nurseries, where stars are forming. When they first start, the very large stars are going to be blue giants, and they don't last too long. They're going to blow up as supernova, which is what I'm going to talk about clusters later on in the evolution. So it's a very active star-forming galaxy. And where they're located at, you have Virgo, talking about spring stars. Here's Spica. And just below that, you're looking at Hydra Gamma, and it's right below that M83. And then just below Alpha Corvus is M68. Okay, Lynx. There's a globular in Lynx. Now this is a fainter one. It's about 10.4 magnitude, and it's rather small, 4.1 arc minutes in diameter. So you need a telescope for this. You're not going to see this with a pair of binoculars. It's the 5th most distant globular known at 275,000 light years distance. That's pretty far out there. Its brightest stars are only 17 magnitude. And of course, the reason you can see it is because you're looking at all those stars in combination, providing a visual magnitude of 10.4. Just to give you an idea how far this is out here, here's the Milky Way galaxy here. It's 100,000 light years in diameter. The sun's about 27 light years from the center, 27,000 rather light years from the center. But you're looking here is the galaxy 270,000 light years way out there. It's actually further out than the satellite galaxies of Milky Way, the large and small Magellanic Clouds, which is at 160,000 and 200,000 light years. Of course, Andromeda is 2.5, so it's way, way out there.
But it's still a part of our galaxy, right?
Yeah, because it's orbiting around, the center of actually this core, the center of gravity of the Milky Way is orbiting. They're all orbiting around the halo, so they're all out there. And they think that this was believed that it could have been a remnant of a dwarf spiral galaxy captured by the Milky Way, but later research disproved this. Okay, there are some that formed on their own, some were actually captured. So it actually orbital period is 3 billion years. So it takes 3 billion years to make one orbit around the Milky Way. Okay, Lynx, kind of an obscure constellation. It's going to be between Ursa Major, here's your Big Dipper asterism, and then Auriga, here's Capella. So it just kind of straddles those two, this location. And of course, here it is again, and we're looking at that globular is right here, 2419, not far from 31, but this is actually Gemini, this is Castor, Castor and Pollux, so just north of Castor. You see that one. That one's going to take a telescope. You're not going to see that with binoculars because it's faint. Okay, I talked about open clusters, the Pleiades and M45 and the Beehive cluster, and then I pointed out 2 globulars to look at for the month of March: M68 and 2419, New General Catalog, and Lynx. And what are the differences between these 2 types of clusters? So what I show here is a Venn diagram, and I'm going to look at the center. What's common between the 2? Of course, here's the globular on the left, and that's typical of a open cluster on the right. Okay, it's a group of stars held together by mutual gravitational attraction. Okay, both characteristic of that. All the stars of the same age have formed from the same cloud of dust and gas. So they both formed around the same time, from the same large molecular cloud. Stars in the cluster are the same distance from the Earth. Obviously, if they're forming in the same location, they're going to be roughly the same distance from the Earth. The star colors in a cluster indicate the age of the cluster. I'll get a little more than that. Orbits the center of a galaxy. Other galaxies have globulars, other galaxies have open clusters. On the open cluster, it's a group of 100 stars. Okay, in globular, we're talking tens of thousands or hundreds of thousands of stars. In fact, Omega Centauri, which you can't see here until you get out of Florida, in the southern hemisphere, is the largest globular, the brightest, and that has 2 million stars. It's not in the hundreds of thousands, it's 2 million. And they think that one definitely was a captured galaxy, the core of a dwarf galaxy that the Milky Way captured. Irregularly shaped, another characteristic open cluster, contains bright blue stars. Because what you're seeing them when they're close together like this, they're young. They're spreading out, a lot of perturbations in their orbit, and I'll talk about later how they're clearing out that nebula, the dust and the gas. They're located in the arms of the Milky Way and in other spiral galaxies. They're going to be in the area where you have a lot of dust and gas to be able to form stars. Composed of young stars that recently formed in distant galaxies and continue to form in the arms of spiral galaxies, including the Milky Way. As long as the Milky Way is going to have a lot of dust and gas, you're still going to get star formation. Later on, the galaxy will become elliptical, there's star forming because all the dust and gas is used up. Globulars, highly symmetrical ball. Of course, that's because the gravity, there's so much there, it's making it a spherical shape. Frequently contains bright red giants because it's old. They're usually, 10, 11 billion years old or more. Located in the halo or bulge of the galaxy. A huge halo, like I showed you that one, it's 270,000 light years away, quite a bit further from, but still orbiting around the center of the Milky Way. Composed of old stars that formed when the universe was younger. So, you're going to see blue giants here, and you're going to see usually yellow stars like our sun's an old star. And no longer forming in our galaxy, the Milky Way. These were formed way, way back. That's why they're so old. And they're not forming anymore.
Question,
Yes.
Since the globular clusters are so, would be more cohesively tracked, why don't they just keep tracking each other until the whole thing collapses? Or does that happen with those kind of?
I think it would be large enough, like what happens, because a lot of astronomers think these are the cores of galaxies. If you have a large enough one, what's going to form in the center of that? A black hole.
Right.
Because most major galaxies have black holes in the center, and you're going to see this huge burst of stars around that with a black hole in the center. So if that had enough mass, or had enough stars, then you would probably form a black hole.
Name, can I ask Tom, can I ask a question? Earlier on, I probably misspoke, and this is a winter galaxy and not, but it's right next to Orion. What is that, M35, 36, and 38? I said
That's the open clusters in Orion.
Yeah, they're open. I had mentioned, I said globular, but they are sort of regular.
Right.
You don't see tens of thousands.
No.
There's 3 of them. I mean, it's pretty unique. It's sort of just into the left side and just off to the left.
Well, they're great for binocular viewing too.
Yeah,
If you're out there
but
looking
they're
at
then.
yeah.
Now I understand they're open. Thank you.
As I mentioned before, M45 is 100 years old, so it's kind of a moderately old, middle-aged cluster, dominated by hot blue luminous stars. The cluster is about 16 light years wide and contains close to 1,000 stars. Now the radiation pressure from those hot blue stars, mainly in the form of UV light, is going to push these original gas and dust from where these stars were formed and push it out. It's called photoevaporation. So eventually you're going to see it, you're not going to see the dust and gas. Now, originally they thought when you're looking at the Pleiades, you can see the nebula all around you. You think, well, that's the remnants of the nursery, the stellar nursery where they were formed. But they found out more recently, in the past couple of decades, that actually is a dusty region, interstellar space that the cluster is actually moving through. So it's not really part of the gas and dust left over from when they were born. Now, if M45 is considered a middle-aged cluster, it is relatively young compared to the solar system, being only 2% age of a 4.5 billion-year-old solar system we have now, but old compared to young open cluster like the trapezium in the Great Nebula of Orion. Now, you need a telescope to be able to split this 4 stars, but there's thousands of stars here, but that's the brightest. With the binoculars, you'll see definitely a concentration of stars. Here's the Orion Nebula, and here's, of course, the trapezium. But what this nebula is actually a stellar nursery. Stars, thousands of stars being formed at the same time in different sizes. Okay, you have blue giants, you can have some dwarfs, you can have some stars like the sun, but the ones that are most prominent, of course, are going to be the blue ones because they're very, very bright. But the brightest stars in the trapezium cluster are less than 100,000 years old. The other stars are 300,000 years old. So after about another 200,000 years, you're not going to see this beautiful nebula anymore. It's going to be gone. All you're going to see is just the stars themselves. And that's all will be left. So this is a very, young cluster. It's probably less than a million years old. Yes.
Yeah, something to add, I learned just the other day. You see a collection of maybe as many as 100 stars right here, but the majority of that open cluster is actually down in here, and it consists of about 2,800 more stars.
Okay, but you
It's
got
hidden
that dark
behind.
nebula right there. It's blocking it. Yeah.
Blocks us.
Okay, looking at the life cycle then. You need a molecular gas cloud, and it's got to be cool temperature-wise to be able to coalesce versus gravity to form and collapse to form stars. Okay, after that's done, stars are forming. The gas and dust of the stars will be ejected, as I mentioned, by stellar winds, the UV radiation, called photoevaporation. After a few million years, the nebula gas will be gone, and the cluster continues to spread out due to gravitational close encounters. In other words, these things are rotating around each other, and of course their orbits are getting perturbed and they're getting spread out. They also are, encounter other objects like large gas clouds in the spiral arms as they're rotating around the center of the galaxy, so that orbits get perturbed. So they get spread out over time. The blue and the red giants will have long detonated supernovae. They're gone. That's why the globular clusters are basically red or yellow stars or some red giants. But the blue stars are long gone. After about a few 100 million years, they're gone. So this is what, of course, M45 looks like now, 100 million years old. This is what it's going to look like. It's going to look like M44, because M44 is 700 million years old. So these are going to spread out. These blue giants are going to have exploded a supernova. And when they explode a supernova, they're going to provide a lot of metal, in other words, heavier than helium. And of course, astronomers say anything that's greater than helium in the periodic table is considered a metal, even though it's not, but that's what they refer to it as. So all the heavy elements are going to be then incorporated in newer stars. That's why the globular clusters are very metal poor, because they formed very, very early on when there was only hydrogen, helium, some lithium, and that's all that was there when they formed 10 billion years ago. But that's what the Pleiades are going to look like in about 700 million years. And that's the evolution. Any questions? Yes?
Am I right that Pleiades is a star cluster?
What's that?
Pleiades, is that a star
That's
cluster?
yes, that's an open star cluster.
An open star.
Oh, yeah.
And how old would that one be? They're spread apart, aren't they?
Well, the Pleiades is about 100 million years old, because they're more spread apart. As I mentioned, the Orion, the open cluster in the center of the Orion Nebula, is less than 1 million years old. And of course, the Beehive cluster, which is an open cluster again, is 700 million years old. So you can look at the very young cluster in the center of the Orion Nebula being less than 1 million years old. Here it's spread out and all the dust and gas is gone, even though that's just passing through some. In 100 million years, you won't see the dust and gas, you just see the stars spread out, and then you get really spread out here later on at 700 million years.
Prettier clouded up like that. So they figured out that they're all those stars are equal, basically in the same
Yes.
plane with respect to us. They're
Yes,
all about
exactly,
the
about the same, yeah. Right. Yes, Jim?
How do they know how old they are? Are they deduced by where they are, or there's some way to?
Well, they look, I don't want to get into Hertzsprung-Russell diagram, but they can look at the color of it, and then they can determine which term is temperature, the luminosity, and they can tell where that is, you know, on the Hertzsprung-Russell diagram. Ours is about in the center as a G-type star, but that's a whole other topic. I mean, we can get into that some other time, but that's how they can tell that. They look at the spectrum too, also. Okay, look at what elements are in the atmosphere by the absorption lines. Okay. Dave?
What is the dust?
Oh, the dust is basically a combination of carbon particles, silica, okay, that type of thing, solid.
Where does it come from?
Well, it actually comes from the supernova that just blew up because they're forming the heavier elements. Okay, and these dust particles are probably the size of maybe 20 to 30 micron, which is about the width of a human hair. They're very, very small, but when you get a lot of them together in a mass, you know, if there's a lot there, like Lane pointed out in Orion, it's dark. It's a dark nebula. And years ago they thought, well, that's just, that area is just a hole in the cloud. You know, I can see out, you know, deeper in the universe, but they found, you know, later on they found out that's actually a cloud of dust blocking the light behind. Yeah, so it's just, they're actually solid particulate. And you got gas mixed in, which is the red color, ionized gas of hydrogen, okay, that's there. So when you get those, gravity forms those together, so that new star, if it has a lot of mixture of the dust, it has a lot of elements like the heavier carbon, kind of that type of thing, and it will then form, and that star will have more of the heavier elements than the star that formed maybe 10 billion years ago, because there wasn't that much dust around, it was gas. Okay, Lane?
Okay, I'll hold it right there.
Okay.
I would just add one more thing. When you look up at the sky, all those stars you see, number one, they're all in our galaxy. And number two, they all came from an open cluster. So, okay. What time is it?
7:32.
Yeah, half an hour.
All right. So, all right, let's see. Plug something in here.
Thank you, Tom.
Okay, just to clarify that, I'm just pondering that. So all, you say all the stars, the individual identifiable stars, we're not, obviously, we're not talking about other galaxies, you know, but every single star is local.
Is what?
Local, I guess is the word.
Yes.
Yeah.
Every star you can see with your eyes, or even in an amateur-sized telescope, is part of our Milky Way. So when we look at it, even the closest large galaxy, like the Andromeda Galaxy, M31, you're seeing combined light of, you know, hundreds of billions of stars. You're not seeing any individual stars in that galaxy. They're just too faint and far away. And by the way, the same thing is true of the Milky Way. When you look at it in the summer and the fall, you know, if you turn your telescope to it, you're going to see more stars in the plane of the Milky Way, but there's still going to be this faint haze in the background, and that's, once again, the combined light of you know, millions of stars, but they're all in our galaxy. All right, let me see. I hope that's, yes it is. New computer, so we're having to get used to it. And all right. We have to make some changes to how this works. Make it easier to navigate, but I'm getting there. What I want to look at is down here, I think this. Nope. Okay, I just plugged a USB drive in, and it's not showing.
The latest version of Windows or something.
What do you think?
Yes.
There's the USB drive.
That desktop picture looks like sitting from sci-fi movies. You know, and God's just around the corner shining his flashlight at us.
All right, all right. There you go. Had it plugged into the wrong socket. All right.
It starts, can't see anything.
That's the way I like it. Okay, what I wanted to do over about the next 15 minutes, and then that'll leave us time to visit and talk with each other, is go over some of the current space missions that are out there and that we can expect results from pretty soon. Worth keeping an eye on. First of all, the Parker Solar Probe. We've talked about this in the past, and you know, it was launched January 19th. Oh, wait a minute. No, it was launched last year, I'm sorry. But it's making loops around the sun. So it's orbiting the sun, but in a very elongated pattern. And when it gets really close to the sun, passing around, from our perspective, the backside of the sun, it's actually sweeping through the atmosphere of the sun, the corona, really close to the sun. And the reason why it's an elongated orbit is as it zooms in on the sun and comes around the backside, it's in some very hot gas, like 1,000,000 degrees. It can't last very long there. And that's when it's traveling the fastest. It loops around there really fast and then leaves that area of the sun and spends a lot of time out here before it comes back in again, because it has time to basically cool down, okay, before it makes another sweep. It's already sending data back, although I've seen no results, no published results from that data yet. But keep an eye out, because eventually, all right.
Hit control click.
That's what I'm doing. Maybe I was just being impatient. This is on the NASA site. And basically, here you are. The green orbit is the Parker Solar Probe right now. Here's the sun, the center. There's Mercury. Right now, Earth is out here. But of course, it was launched from Earth when Earth was over here. And the Earth was right there. It was launched, followed this path, made its first sweep through the corona, came back out. It's right about here now, preparing to go back in. These red loops show how close the probe is going to be to the sun in future passes. So this is going to be operating for the next several years, if I remember correctly. There's a lot more information here on the NASA website. And let's see if I should be able to go straight to the master. Okay, here we go. Missions. So if you just go to nasa.gov, that's it, real easy to remember, nasa.gov, hit missions, Parker Solar Probe is right there, and you can get more information on it. Now the main thing that they're after is to try to figure out why the corona is so hot. Does anybody know how hot the surface, the visible surface of the sun is? Roughly.
It's about 25 now.
No, way too high. What?
5,600?
5,600 K.
Yeah. That's Kelvin, it's, I think it's up close to 8,000 Fahrenheit. But the point is, we can actually create something that hot here on Earth with no problem in a laboratory. But the problem is that you would think, Tom was talking about the stellar wind, which is mostly charged particles being pushed out of a star, like the sun. That those particles should cool down the further away they get from the sun. And that's not what's happening. In fact, partway out from what we see as the surface of the sun, they actually get hotter and hotter, upwards of 1 million degrees. And the Parker Solar Probe is going to help us figure out why. What's that heating? Yes?
What material is that made of to withstand that kind of?
Mostly hydrogen.
No, the probe.
Oh, the probe? Okay, you can find out on this website, but it's some fairly exotic material. So there is like a heat shield that sits there, and it's always oriented towards the sun. But even that heat shield cannot take the heat of a close pass to the sun for long. That's why it has to sweep in and then come back out and cool off and recover. And all the instrumentation sits behind that heat shield. And it's a carbon-based shield. I've forgotten exactly what it is. I gave a talk about that composition, a year ago, I think. And since it's more than 3 days ago, I don't remember what it is. Okay, so go check it out on the NASA website. Now, next tab. We have 2 asteroid sample return missions out there. One of them is from the Japanese Space Agency, which is usually known as JAXA. And that's at has rendezvoused with an asteroid called Ryugu. And typical of asteroids, it's not very big, it's pretty small, has very little gravity, very tricky maneuver to actually park a satellite around them. But they managed to do it. And that particular probe, Hayabusa 2, because there was a 1 previously, a few years ago, it actually has a couple of landers, as well as one of those landers, and they're all pretty small, about the size of a cigar box, by the way, is actually going to go down to the surface, collect a sample, and bring it back to Earth. And you can find out a lot more information about that. Notice it was launched in 2014, and it arrived at the asteroid in 2018. Asteroids are not very far away, so why in the world would it take 4 years? Well, you gotta go really slow if you want to enter orbit around an asteroid, because the gravity is so weak that if you fly by too fast, you just keep on going. The asteroid might curve your trajectory a little bit, but it's not going to really slow you down much. So it takes time to get to an asteroid because you have to go slow. And let's see, what else here? By the way, I think, if I remember correctly, it's already collected the sample.
Is this particular one in the belt somewhere, or is it?
It's in the asteroid belt, yes. Yeah, it's already collected the sample. You can read more about it. Once again, it's on let's see, what's yeah, it's okay. It's on, no, that's NASA. Okay, I seem to have lost the link to that, so you'll just have to Google it. Yes, in the back.
What's the name of the first probe? Not hydrogen, two, but
The name of the what?
probe.
Parker Solar Probe.
Parker Solar Probe.
The asteroid.
Oh, the asteroid one? That's the name of the spacecraft. Okay, the name of the asteroid is RYUGU. Okay, next. Come down to OSIRIS-REx, which is the NASA spacecraft that is out there in the asteroid belt collecting a sample. It's an asteroid, how do you pronounce that? Bennu. Launched in 2016, will reach Bennu in 2018, so it's already there, and return a sample in 2023. And I don't know why the word New Horizons is there. Forget that, I guess I copied too much.
They did have a another release of Ultimate 2.
They have what?
And a fairly recent release of a newer image of Ultimate 2 New Horizons.
Yeah, but that has nothing to do with the asteroid mission.
No, but you were asking about why New Horizons.
Why is it there? Yeah. I realized I copied too much as I scanned down.
Are they expecting certain things to show up in the samples that come back, you know, like ferrous, base, you know, iron?
Why would you bother then to collect, I think you're asking, a sample from an asteroid? Anybody want to answer that?
Well, because going in, don't scientists typically sort of have hunches about it?
They do.
Solar system formation?
Yes, exactly.
Oh,
In other words, the asteroid belt is full of material that has not been processed. Think about this. If somebody on Jupiter sent a probe to Earth to gather a sample, you know, depending on where they landed, the sample that they took, like for instance, the age of the sample could be anywhere from about 4-point-something billion years to a few hundred years. Okay, because the surface of the Earth has always been processed. But that's not going on in the asteroid belt. Very little processing has occurred. Yes.
So did they pre-select the asteroid that they're going to be,
Yes.
going to be landing on?
Yes.
Do you have any idea what kind of criteria they use for that?
No.
The selection process?
Sorry, I don't know the answer to that. But I guarantee the answer is here on this website. They have lots of information there. Tom?
Just a comment. The asteroids, of course, date back to when the solar system was formed, as Gary pointed out. But, you know, a lot of the meteorites that we land on the Earth are from asteroids.
Right.
And I think the fascinating thing is a lot of them have, when they're analysis, have amino acids in them.
A lot of them have what?
Amino acids.
Yes.
Which are the precursors of proteins. So, so they can find more different compounds in a pristine state. Okay, I think that's what they're looking at, because obviously a meteorite that's on the Earth here absorbs water and other things like that, and this way you're going to get something that's not contaminated.
And by the way, that's why astronomers here on Earth, when they're looking for meteorites on Earth, they're looking for meteorites that haven't been sitting around a long time. I mean, that's why they love Antarctica, because the meteorites that land there become encased in ice typically, and they'll stay that way for a long, long time. So the only thing that, when they analyze them, the only thing they have to worry about is the water it absorbs. Everything else should be about the same as when it was out in the asteroid belt. So they're after pristine samples, right, of the early stages of formation of the solar system.
Lane,
Yes.
just actually going back to the Parker Solar Probe, it's going around 24 times. then what? Are they gonna like crash it in with the sun, get some last ditch measurements, or will it keep going around, do you know?
I don't know the answer,
I'll look it up.
sorry.
Looked like each orbit was like a little closer.
Yeah, it looks like it's getting closer and closer, right?
They get
Maybe
these-
we won't make it 24, but knowing NASA would probably see, well.
Okay, Mars Insight. Once again, it's on the NASA site. First mission explores Mars' deep interior. Well, depends on what you call deep, but it's making an effort to go, I think, like 10 or 20 feet below the surface.
You heard the latest,
It's got a probe,
About 16 is what they're targeting.
16? Okay.
You hit an obstruction
in the
there.
right category.
Well, right,
Yeah.
that's new news.
Yeah, just a couple inches down hit an obstruction, not going any further.
Anybody's ever dug fence posts?
When it dug in, it went in a couple inches and stopped, it's hitting an obstruction.
They're still trying to figure out
Yeah.
what to do about that. Now, that probe is designed to, if it hits something, go sideways and try to get around it, but I don't think they've tried to do that yet. So the probe is in early deployment. It does have a seismograph on it, so at least that's working, and several other experiments, which you might want to check out on the website. So the point is that we should be hearing more information about that over the course of this year. That should be fun to follow. And of course, that's on Mars.
It's also tracking the weather as far as temperatures and winds, so
Okay.
if you think it's cold here on Earth, you can check out
Yeah.
Mars' weather.
Interestingly enough, it can get above freezing on Mars, but the atmosphere is so thin, you wouldn't, as a human being, you wouldn't be experiencing a balmy day, so because, well, you're getting into the problem of how do you measure heat? And here we do it in a very gross way. You know, you walk outside, is it cold or is it warm? But when you've got so little atmosphere to work with, like on Mars, or the sun, by the way, you can't measure temperature the same way. But that's another talk. Okay, so Mars Insight, check that out. Once more, if you just go to the NASA site, all the information you'd ever want to know is right there about Insight. Okay. How many people have been
16 inches long.
following SpaceX?
It's on my way.
Fun stuff, making a lot of progress. The Crew Dragon, does anybody want to give us an update on that?
It took off. It docked with the space station.
They docked, yes.
And there's a dummy inside, it's like a crash dummy that collects data. And two of the attendants at the space station.
Speak up a little more, please.
Two of the attendants on the space station went inside the Dragon and
Okay.
checked it out.
So this is, I believe, the first time that a commercial product has gone into space that's prepared in the near future to carry humans. And there will be others, guaranteed, others in the works. Boeing has one, and I think there's one other.
Blue Origin, or,
Yeah, I think.
but I don't think they're looking to dock at the space station. I think they're just looking to go up and come back down. Blue Origin,
Yeah.
I think.
Yes,
Yeah.
yeah. That's purely space tourism.
Yes.
But this one has successfully docked with the space station. No one's on board. Nobody went up on board. But they're talking about maybe as early as this summer, sending human beings up to the space station that way. And of course, it's designed to come back down. Unlike the Soyuz craft, we currently pay probably too much money to the Russians to send up. This one lands on water. Soyuz lands on land. So that's probably principal difference. And of course, the technology on board, the Dragon is much more advanced than the Soviet system.
They do a really good job broadcasting these rocket launches with SpaceX. I didn't get to watch it live because it was like 2:30 in the morning, but I watched the replay and stuff. And you could see a replay, and first of all, it's cool to watch it launch. The better part is watching the first stage come back and land on a drone ship.
Yeah.
It's just, I don't know, like my heart beats every time, well, it's beating all the time, but you know, like it just gets me every time to see a stage of a rocket land so softly right back on Earth. It's remarkable.
I almost got to see that firsthand a couple of years ago down at Kennedy Space Center. But my impatience did not do well. They canceled the launch that day, and I looked at the weather report, and they rescheduled for the next day, and I said, it's not going to go tomorrow, it's going to be raining and all that stuff. So I went ahead and left. I was on a trip down to the Keys. And sure enough, friends of mine who waited saw it happen. They saw the first stage come back and land. Very well. Okay, we're going to stop there, but I would just mention there are one rover running around the moon right now. It's Chinese. They're not telling us much other than it's working okay. That's it. And, we'll see what happens. It's on the far side. Is there really a far side of the moon?
Yes. Well, there's no dark side.
From Earth's perspective, yes. But there's no such thing as a dark side. And the Israeli, it's a lander, not a rover, but that's totally commercial. It was put up on a SpaceX rocket not long ago, last week sometime, I think. Yeah. And it's on its way, it's having a few problems, but it's supposed to make a soft landing there, we'll see.
Mazel tov.
Amen. And let's hope it's soft, yeah.
It's actually one of the remnants from the Google Lunar X Prize from years ago. They had competed in that. And,
I've forgotten about that. Yeah.
Do you have that show at the North Museum?
I do, yes. It's a little outdated now, but no one ever won the competition.
Right.
Okay, we've got, about 5 minutes to clear out. Can we have the